In this module, we will review the math behind decision trees, a tool and technique to perform quantitative risk analysis. In the last module, we discussed how expected monetary value could be used as a simple quantitative modeling technique to generate a evaluated understanding of risk using two simple risk factors, the probability and the impact. However, it is rare that the analysis of a risk event is so two-dimensional. How can we evaluate risk when the occurrence of an event results in multiple possible outcomes? For example, the threat of a hurricane could have multiple varying probabilities and impacts based on what category the hurricane is. Further, there could also be some opportunities presented, such as economic relief, if it turns out to be a national emergency. For complex scenarios such as this one, decision trees can be used to help apply expected monetary value when multiple outcomes are possible. We will explore some simple examples to help prepare you for the exam. It is useful to know that decision trees can be quite complex. They can be linear or nonlinear, and there can be multiple layers where choosing one decision leads to another decision to be made. In this exercise, and to prepare for the exam, we're going to focus on a simple example to make sure we understand the basic concepts. Let's begin by reviewing the language. On our project to develop a cell phone, we can either make or buy the processor chip. The rectangular shapes for make and buy represent the decision nodes. Each decision may result in one or usually multiple possible outcomes. Each circle is a chance node, representing an event that may or may not happen because of a decision. Their probabilities and impacts have been given in this example. Our goal in a decision tree is to decide which decision would be best. To do this, we must determine the outcome or consequence for each chance node using our expected monetary value formula. Once we have determined the consequence of each chance event, we can aggregate them by adding to find the total expected monetary value for the decision. When all other factors are held constant, the decision with the greatest overall expected monetary value should be chosen. Let's practice using this example. We'll begin by calculating the consequence or expected monetary value for chance node 1. $10 million times 0.75 equals $7,500,000. For chance node 2, we will multiply 0.15 by negative $1 million, which will be negative $150,000. For chance node 3, we will multiply 0.85 by $9 million, which will be $7,650,000. And for chance node 4, we will multiply 0.10 by negative $500,000, which will be negative $50,000. Next, we will add the consequence of chance node 1 and 2 to find the total expected monetary value for the make decision. 7.5 million minus $150,000 is $7,350,000. Finally, we will add the consequence of chance nodes 3 and 4 to find the total expected monetary value for the buy decision. 7.65 million minus 50,000 is $7,600,000. Since we will choose the decision with the highest expected monetary value, we would buy the processor chip in this example. Keep in mind that the real-world application of decision trees can be quite complex. However, They can be useful to model risk scenarios that have multiple possible outcomes. For the exam, be prepared to solve simple examples and know the language, such as decision nodes, chance nodes, and consequences.